So most of the electrons are accumulated in downward direction. In this case of equilibrium condition, what is the, for example, if this is opposite phases are created positive charges at equilibrium condition, there is either continuously applied field, some electrons is supposed reflected to this electron, that condition will be called it as equilibrium condition. So that equation, this is equation number 1, this is equation number 2. For example, applied magnetic field, some electrons are moved to downward direction. So at equilibrium condition, equation number 1 equal to equation number 2. So equating potential difference in a magnetic field, what was the equation? Minus E into E is equal to B E B. In this case, minus B, minus will cancel, E cancel, and then what is the remaining term? B into B. E is equal to B into B. And the next one is we find out the velocity value. So, what is that equation for current density value? Already very well known about current density value. So, what is the equation? J is equal to NEB. So, in this case, we are calculating, we take it as Jx and then NE. Jx, this is the derived value, very well known about current density, and EB. In this case, x is denoted by applied electric field in x direction, current value. Ne is denoted by, E is denoted by, in this case of n-type semiconductor, majority charge carried is electron, so denoted by E. So we find out the value of P. So V is equal to, what is the value? Jx divided by, J is divided by Ne into E. This is the value for V value. This is equation number 3. This is equation number 4. And then equation number 4 substituting equation number 3. What is the value of V? So E is equal to equation number 4 in 3. And then what is the final equation? E is equal to B into, what is the value of B? Jx divided by Ne into E. So in this case, very small changes in Jx equal to Ne into B. In this case, n-type semiconductor, majority charge carried is electron. So current density is replaced by negative symbol. So here also present in negative, and here also put it in negative symbol. Okay, this is equation number 5. And then next one is we find out the value for Hall coefficient. Next one is Hall coefficient. So E is equal to RH into Jx into B. This is the value for E value. In this case, RH is denoted by Hall coefficient. RH is known as Hall coefficient. Hall coefficient. In this case, RH is equal to minus 1 by Ne into E. This is the value of Hall coefficient. In this case, negative symbol is denoted by Hall potential is created by negative y direction. Okay, this is the Hall coefficient in n-type semiconductor. In this case, in n-type semiconductor, majority charge carried is electrons. Electrons are accumulated in down phase 2. Phase 2. This is the phase 1. This is the current carrying material. This current carrying material is connected to the voltmeter. That is battery or voltmeter. B is plus and then minus. Okay. In this case, here I already told that in x direction applied electric field, and then what is the z direction is applied magnetic field, and then applied magnetic field, and then y direction is nothing but creating potential difference. In this case of n-type semiconductor, negative y direction, the Hall voltage is created. For example, to apply electric field, to apply magnetic field, some electrons are drifted downward direction. In this case, all electrons are drifted to downward direction. In this case, downward direction, most of the electrons are present in phase 2, and this is the phase 1. In phase 2, to create a positively charged, so that is the value of E into EH. In this case, EH is denoted by charge. In this case, we talked about Hall effect. So E is energy. Applied field is nothing but Hall field. So that force due to potential difference is E into EH. Okay, what is the value for magnetic field? BeV. And equilibrium condition, magnetic field and then current also equal. So, and then after introducing the current density value, J is equal to NE into V. So find out the voltage V value. V value is equal to J is equal to NE into V. And then finally we calculate Hall coefficient. That Hall coefficient is nothing but RH value. RH is equal to minus 1 by NE into E. This negative symbol is nothing but always the creating potential always in negative y direction. Okay, thank you.